Okay, so today we are talking about solving trig equations. This is our second try.
So do we need to not know trig?
Absolutely.
I thought we already were known trig.
Yeah, you did. So you might be okay being a little bit less specific. Okay, so as we get started, here will be our example problem. And then we'll talk about how we get our answers. So our problem is we're going to solve 2 cosine of 2x equals, let's say, 1. We do have to get this piece, the trigonomic piece, alone. So in order to get that alone, I'm going to need to divide by 2. So I divide by 2, and I get cosine of 2x equals a half. Now at this point, I'm going to think, alright, where is cosine a positive half? So that's where I think of this quadrant thing that we made the other day, where we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we think about, well, what is cosine, sine, and tangent as far as their sign? And in quadrant 1, cosine is positive, sine is positive, and tangent is positive. In quadrant 2, cosine is negative now, sine is positive still, and tangent is negative though. So if these are opposite, then your tangent is opposite, or negative. In quadrant 3, cosine's negative, sine's negative, and tangent is positive. These are the same, the tangent is positive. And finally, in quadrant 4, cosine's positive, sine's negative, and tangent is negative. So we already have this somewhere in our notes, but it's worth talking about again. And the reason for this is because cosine has to do with x values, sine has to do with y values, and tangent is really sine over cosine, so y over x. So if I do negative divide a positive, I get a negative, which is where that comes from. Alright, so I need to think about that. So this is saying in our equation that cosine is a positive a half. So if I draw a reference triangle here, I have my unit circle, and you don't have to do this every time, but I'm just going to draw my reference triangle here. I'm thinking, where is, now cosine would be this length. That's my x value, that's my cosine. Where else would it be positive a half? Well, it's not going to be a positive half over here because cosine is negative. So it could be over here. So it could be a positive half right here. Even though sine's negative, the cosine's still a positive half. So I have 2 answers going into this. I have an answer in quadrant 1 and an answer in quadrant 2. This will likely, although not always, give me the answer that's in quadrant 1. Okay? So at this step, I take the inverse cosine. And when I take the inverse cosine, so 2x equals inverse cosine of a half. What do we get?
60.
Wait, I have a question.
Okay, so we get 60, and your question is?
Why would it be in quadrant 2?
Oops, you're right. I'm a dumb butt. Quadrant 4 is what I meant. Thank you. Good catch. That would have thrown our answer off. Okay, so here we go. And then we did our inverse cosine, and now
60.
It's 60. I jumped ahead. And then it's 30, because we're going to divide by 2.
Gosh.
So we get 30. Math today. Alright, so there is our quadrant 1 answer. This quadrant 1 answer gives us a reference angle. And our reference angle is 30. Which means when I go up to this little diagram here, and I'm just going to draw again so that it's a little bit clear. The reference angle in our quadrant 4 is 30. But what I want to know, because I'm not going to measure that angle this way, going backwards, I'm going to measure it this way. So I want to know that angle. And the way to get that is going to be 360 minus 30. So 330. So that's going to be my other answer. X equals 330. Now if at any point you forget how to do this, remember I can go back to this part, and like we did yesterday, I could say y1 in my graphing utility is cosine 2x, y2 is a half, and then I g-solve or calc, depending upon your calculator, and then we look for the intersection. And we'll see that there are 2 answers there.
There's 3.
3 answers. I'm missing
4.
4 answers. I'm missing one. What one am I missing? Which 2 am I missing? Since you're doing that.
Is that 1/2?
Yeah.
210.
210. And
I don't know.
and 150. So now I have answers in these 2 quadrants as well.
So you'll box those answers as well?
Yes, I'll box those answers as well. But the question we need to ask is, well, how am I going to get these 2? With my calculator. Well, we certainly could do that. We could use our calculator and figure out why we are getting these. We want to know how we are getting these 2 extra answers right here. Well, it's because my wavelength is doubled, or I have 2 complete waves going from 0 to 360. So that means that I double essentially the number of answers that I have. But how would I get these 2 answers without doing what we just did? Well, one way would be to say, let's see here, let's clear all of this. One way to do it would be to say, alright, well, my wavelength is now 0 to 180, right? That's my new wavelength, which means I have, when I do my graph, here's 180 and here's 360. We want all the answers from 0 to 360. Okay? So what's the cosine of 0? Well, 1, right? So I have basically this, and then I have another one, 0 to 360, when we did our drawing of graphs the other day. So when we put in a half, we're getting this, right? Something right there. And the 2 answers that we got this one right here, and we got this one over here, but we're missing the 2 in the middle right here. The 180 ones, the quadrant 2 and the quadrant 3 answers. So one way to get this would be to take our 360, because we normally go 0 to 360, and we could how could we do this? 180 minus our 30 gives me the 150 answer, and the 180 plus the 30 reference angle gives me the 210. But why? Because what is cosine in quadrant 2? What's the sign?
Negative.
Negative. And what's the sign in quadrant 3? It is also negative. But I need to remember that because I've doubled my wavelength, I've actually completed an extra wave. So this one is actually, when I graph it this way, I see that it's on, see, these are positives, right? And these would be the negative answers. So I've doubled that. Let's do another and see if we can clear that up a little bit. Next one. We'll say cosine of, we'll do a 2x again, equals 0.25. So this is already alone. So what do I need to do? Inverse cosine. So 2x is going to equal inverse cosine of 0.25, and I get
75.5.
75.5. And then we would divide by 2, and x equals
37.8.
Okay, so we're going to start just like we did before, but this time we're going to account for the extra answers. Alright, so that cosine is positive in quadrant 1 and quadrant 4. So we have two answers coming from that. So here's our 37.8. So I need this one. This is 37.8 as well. I need to know this angle. So I'm going to get my 360 minus the 37.8. Say again?
322.2.
Okay. And now, let's do the 180, because we have two waves that are going. So the 180 minus 37.2, and what do we get for that answer?
142.2.
142.2. And the 180 plus 37.8.
37.8.
To what?
17.8.
So these are all my answers. Give you a moment to write that down.
Wait, when I did it on the calculator, I didn't get a 27.8.
That's 270.
217.
Now that makes sense. I did get that.
You're not trusting yourself in here.
No, I trust you. Okay, let's do another. Alright, here's our other. -3 cosine of x.
Can we do a sine?
Yep, we will, definitely. We won't do tangent today. Maybe tomorrow we'll do a tangent. So what do we do first?
Divide by -3.
Divide by -3. And what do we get?
-0.8 per repeat.
And now what do we do?
Inverse.
Inverse cosine. And when we do inverse cosine, we get
146.1.
okay. So now this time, is my wavelength double or halved? Do I have two complete waves? No, just one complete wave, 0 to 360. So now I do not have four answers, I have two answers. And the first answer is in quadrant number 2. Notice the sign. This is negative. So where else is cosine negative? In quadrant 3. Okay? So what we have found with this 146.2, we've actually found this angle. Okay? Now we need to know this quadrant 3 angle. I need to know this one as well. Now there are a few different ways to get that. One way is to do 360 minus the 146.1. And what do we get if we do it that way?
$13.9.
213.9. Okay. Another way to get it would be get my reference angle, get this thing in here. So if I know that, which would be 180 minus 146.1, so what do we get when we do that?
33.9.
So 33.9, that's my reference angle. If I add that to 180 now, I just go the other direction. I get 213.9. Probably the easier way is to do the 360 minus, because if this right here is 146, then I can get this one right here by doing minus 360. Well, this subtracted from 360. So I only have two answers this time. But that's because I only complete one wave. And how can we check our answer? Well, we can put in y1. Now, if you really wanted to, you don't even have to go to this step. You could go to this step and do, all right, y1 is negative 3 cosine x, and y2 is whatever's over here, 2.5, and then do your g-solve from the very beginning. You'll get the same answers. Alright, so these were our two.
If we're more comfortable with doing that, can we do that?
Yes, absolutely.
Okay, that's what I've been doing.
So I do want to definitely see the math to get the first answer.
Yeah, I do that, and then for
Yep.
the rest of them, I just use my calculator.
That's certainly fine. You can make use of your graphing utility. All right, I'm going to put a few up here, and I'm going to, after I put them up, I'll put up the answers, but I want you to work them on your own. Okay? So here they are. Example 1. These will all be cosine ones, and then we'll do some. You can start working on them. Then we'll do some sine examples. This one has something different that we haven't talked about yet, but we'll see if you can get it.
Mr. Kane.
I'm stupid. Read that, devil.
My ugly face.
Okay, guys.
So you gotta do the same thing for this side?
So we can get the first answer and then use our calculator.
Yep.
Our calculator. Got to do. Boom, boom. Is it okay if we all round it to the nearest tenth?
Yes.
Okay. 'Cause that's what I do. How come there's a question mark right there?
I'll get back to it, talk about that one. And actually, this one has a thing too.
Does it only have one answer?
Like I said, we'll come back and talk about it.
I'm sure Kane wouldn't that be 209? Because it's like 208.95.
Yes.
That's the most organized I've seen you writing that thing on.
Thank you.
Does that one have a thing?
The last one?
Yeah.
No, because we've already someone talked about it.
Mr. Can, if you could eat anything right now, what would you eat?
I have no craving right now.
You just rolling up with them.
Yeah, I know.
But you're okay. I forgive you.
That's nice of you.
Don't do it.
Too late, up on you. No, Betsy, Betsy.
Some kid told me he's going to the King Country.
Oh, cool. Sweet.
But he made it sound like he was going there.
Well, maybe he is.
That's what he-
Hey Grant,
Hey.
are you going with him across the country?
Good.
Cute.
Mm-hmm. No, shit. It was
Were you
too
late?
It was too
Did you not get your green card? That's for going into Mexico or coming back to America.
My passports came in 5 days after it was due.
Maybe next year.
Hey, you got a passport, though, son.
Next year.
You got a passport, son.
Yeah, good.
That means you can go to anywhere in the world you want.
myself.
You can go to Italy if you want Hey.
Yes.
Just want to give you an update on chapel schedule. I have moved you into next Wednesday, if that's okay.
Fun. Sure, I'm fine.
Although I might also use that
I will rip your hand off.
that day as an opportunity.
Okay.
That means so much.
Oh, that might influence what I talk about.
We can talk about it.
Yes, we definitely should talk about that. And Clinton Communities definite on April
On the
12th.
2012.
On the 12th, April
Yes.
12th. Yeah.
Yeah.
Yes. Okay. Any wrap up those questions? Okay.
So what are you doing chapel on, Mr. Kane?
You'll find out.
I thought
Is that a picture of
I don't know.
Ashley? Ashley, Mr. Kane drew you.
What? I haven't looked up in like
Okay. I'll take it that we're good. Let's talk about this one. So, for all right, I'm gonna in green right here just write a few things. All right, so if I have y equals cosine of 2x, how many waves will complete 0 to 360? Two waves. Two waves. Okay? And if I had y equals cosine of 5x, how many waves will complete 0 to 360? 5 waves. Good. Okay? Now, let's talk about that. If I have y equals cosine of a half x, how many waves complete 0 to 360? Half of a wave. So how many waves complete 0 to 360 right here? 1/4 of a wave. I don't even get a whole wave. So we don't need to worry so much about repeated answers here because we are not getting repeat waves. We're only getting part of a wave anyway. Same thing here. How many waves do we get? A half, or 0.5 of a wave. So I don't need to worry about repeat answers because I'm not even getting a complete wave. And then we already talked about this one. We get 2 waves completing 0 to 360, so we have extra answers to account for. Okay, let's do some examples with sine. Sine is going to work the same way, but our explanation is sine is positive here, here, and negative in those 2 quadrants, okay? Because sine has to do with y values. So let's do sine of 2x equals 5. What happens? I do the inverse sine, and I get 2x equals, what's the inverse sine of 5? We can't do it. And here's the reason why. Values of sine and cosine go from -1 to 1. They never go bigger in magnitude than -1 and 1, which means this is an impossible situation. And the reason is, if I have a right triangle with a hypotenuse of 1, okay, and this is where all of our sine and cosines are coming from. Remember, this would be our cosine, this would be our sine, okay, sine having to do with y values. The hypotenuse is always the longest side, which means sine and cosine would have to be less than 1, right, or equal to 1 in magnitude. So we get an error in that case. All right, but so this would be no solution.
No solution.
All right, so let's do sine of 2x. Now let's do one that actually works out. Let's do 0.2. Let's do 5 sine of x equals 0.1. Let's do those two. Let's do them together. So we do inverse sine of 0.2. So sine, or 2x equals 11.5. And then we divide both sides by 2. 5.8. Now, I'm going to have different solutions this time because sine is positive in quadrants 1 and 2. So my next answer will be 180 plus or minus that 5.8.
Minus 5.8.
Minus 5.8. Because look which quadrant we're in. We would be, here's our 5.8 as a reference angle. So I need to know this angle. So that's going to be 180 minus that.
Wait, I don't understand where you got 11.5 from.
Someone said that we did inverse sine of 0.2 and got 11.5. Is that correct?
Oh, yeah. Okay, yeah.
Yes. And then we divided by 2. And then this is now our reference angle. Okay? And now we would get 180 minus the 5.8.
174.2.
Yep. So 174.2. Oops. No decimal point there. So 174.2 degrees. Okay. Now I need to get, because this was a 2x, so how many waves complete? How many waves complete?
2.
2. Alright, so let's just quickly sketch this. Sine of 0 is 0. So here's 0 to 180. Here's 180. And here's 360. So sine does look different than cosine. So sine is 0 right here. It'll be a 1 right at 90. So right here. So we should get something like this.
So we only get 2 answers?
No, we do get 4. So 0.2 being somewhere, are we paying attention? Somewhere down here. Alright, so we get an answer there, 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 and there. Alright, so we have extra answers. Alright, using your calculator, what are the extra answers?
185, 8, and then 354.
354.2.
You should know.
I didn't like calculate it. I just
Okay, so we get,
typed it.
these are our extra answers.
Yeah.
Okay. What do we do first over here?
Divide by 5.
Yep, so we get sine of x equals was 0.1 divided by 5.
102. Inverse time.
Inverse sine, so x equals
1.165.
so about 1.2 degrees, is that fair? Okay. Now, I don't have a double angle thing going on, but sine is not positive in quadrant 4, it's positive in quadrants 1 and 2. So I would take that and subtract it from 180 to get the quadrant 2 answer. So I get 178.8. Is that correct? Okay, so those are our answers. With the time that's left, I do want to do 2 challenging questions. These are the most challenging of the challenging. You ready?
No.
Alright, here we go. 5 cosine squared of 3x equals, I don't know, 8. That's fair. And let's do sine
You want us to do
squared. We're going to do them together. Now you lost my train of thought.
I'm sorry.
It will die.
Stop doing it,
Equals
1.
1. Sure, why not?
Yeah.
Okay. What do we do first?
Square root it.
No,
Not yet.
Divide by 5.
Divide by 5.
That's what I meant to say, but...
So cosine squared of 3x equals
1.6.
1.6.
Now you square root it.
Now we square root it. So what's the square root of that?
1.3.
1.3. And at this point we can stop, because when we square root that,
1.3.
okay, the square root of 1.6 is 1.3, you said? Okay, so at that point we can stop because we can't inverse cosine that, so no solution. Alright, so that one was way easier than I thought. Let's change these numbers. Let's change this to an 8. Let's change this to a 5. So now we do 5 divided by 8. And what do we get?
Huh?
Now we solve by dividing by 8. 0.6. Well, we want to keep a few decimal places, so 0.6 what? 25, okay. Because that'll throw off our answer if we round too soon. Now we inverse. Now we do not inverse cosine yet because we have this squared right here. So we have to square root both sides.
0.8.
So cosine of 3x equals, you said
0.8.
0.8. Okay. Now we can inverse cosine. Now wait, how many waves complete?
3.
3 complete waves. So maybe 6 answers here. But actually, maybe even 12 answers. Here's why. Up to 12. Here's why. When we take the square root, we have to account for the negative version. So we also have negative 0.8. So we have to solve this one and this one. So let's inverse cosine this one on the left-hand side. Are you getting this down?
36.9.
So we inverse cosine and we get 3x equals what?
36.9.
36.9. And divide by 3.
12.3.
12.3. And inverse cosine this one. So 3x equals
Negative 12.3. Or
Oh.
143.1.
143.1. If we were for some reason to get like a negative degree answer, we add 360 to it, right? Divide by 3 and we get what?
47.7.
Okay, so using our calculator now, go back up to this step, and in y1 we'll put in 8 cosine squared 3x. In our calculator we might have to type it like this: 8 parentheses cosine parentheses 3x, and then put the square root right there. Because I don't think your calculator supports writing it like this. So you have to put all of this stuff inside, and then you have a square on the outside. Note that does not mean that I get 9x squared in here. It means the cosine itself is squared. Alright, then y2, we'll put in 5. Now, we need to do a view window adjustment. So our view window, our x min is 0. Our x max is 360 because we're solving 0 to 360. But now our y min and our y max we're going to have to adjust. Well, why? Because I'm looking for answers that go up to 5, right? So I might adjust my y min. Right now it's negative 3 and 3. Usually that's what we have. But now we'll do, say, negative 6 to 6 because we're expecting an answer here in the realm of 5. Okay? Using your intersection, what are some of the other answers that we get?
Oh, good Lord.
Wait.
47.4.
Okay, 47.4. That might be this because we did some rounding. So hold on. What'd you say? 72 point what? Okay.
Or 6 if you round. 0.6.
Okay, 0.6 if we round. Okay, how about the other ones?
107.4.
107.4 you said?
Yes.
Okay.
132.6.
132.6.
167.4.
167.4.
192.6.
192.6.
227.4.
227.4.
252.6.
232.6.
252.6.
252.6.
287.4.
287.4.
312.6.
312.6.
And then 347.4.
Hold up. So, surely we can find a better way. But yes, we list all those answers. Alright, you may go. And we are now basically done with section 3.5.
Yay! Wait a minute.